Alright guys, today we are looking at 1.3, which is kind of going back a little bit to just linear equations, but today we're going to be focusing specifically on word problems. So what we're working on today, this should be a review of what we already knew from Algebra 1, so hopefully this is an easy day for us. It's just going back to kind of how we can set up and solve those linear equations when they're given to us in a context. So I'm going to do this and kind of break this down into two different parts. This first page here is all writing our equations in slope-intercept form, which if you don't remember, slope-intercept form is right here, y equals mx plus b. In order for us to be able to use that, we need our slope and we need our y-intercept. So m is our slope, it's going to be a rate in our problem, and then b, our y-intercept, is some starting value for our problem. So in this first one here, number one tells us that we have an airplane that starts 30,000 feet above the ground and begins to descend at a rate of 2,000 feet per minute. We're supposed to assume that the plane continues at the same rate of descent. The plane's height and minutes above the ground are related to each other. So this next set of kind of sentences here, statements here, these are just kind of for you to help guide you to our solution. You don't necessarily need to fill out all of these different things in order to solve the equation. A lot of you will just kind of do this naturally or without having to write it down, because really your two problems that we're asked to do here, A is write an equation for the model, to model the situation, and then B, we're supposed to be using the equation to find what the altitude of the plane is after 5 minutes. So just to start with, it's sometimes helpful for us to define what those x and y values are, so we know what's the independent and what's the dependent variable. So here they tell us that the height and the time above the ground are related to each other. So here, since we're talking about the rate of descent of a plane, the x value is definitely going to be our time. So it's going to be our minutes above ground. And then y is going to be our resulting height. I don't know why I keep trying to put an F in height. So that's what we're given. The other thing that we're given is that we are starting out 30,000 feet above the ground, and they also tell us the rate of 2,000 feet per minute. Now that rate, again, that's going to be our slope. What we have to be careful of here is that we're descending at a rate of 2,000 feet per minute. So our slope is actually going to be a negative 2,000, because every minute that goes by, we are losing 2,000 feet of our altitude. The other thing that we're given is that we're starting at 30,000 feet, which is going to be our y-intercept. So 30,000 is our y-intercept, that's our b value, and then negative 2,000 is our slope. That's going to be our m. So pretty straightforward to write our equation. Y equals negative 2,000x plus 30,000. And that's going to be our equation. For part B, we're trying to find the altitude after 5 minutes. Well, 5 minutes is a time, so that's going to be an x value. We're going to plug that into our equation. So y equals negative 2,000 times 5 plus 30,000. So negative 2,000 times 5 is negative 10,000 plus 30,000 tells us that we're going to have an altitude of 20,000 feet. Pretty straightforward. For number 2, similar. Here we're starting with the fact that we've received $100 for a graduation present, and you deposit it into a savings account. Then every week after that, you add $5 to the account, but this is not a situation where we are earning any interest. So the amount in the account is a function of the number of weeks that have passed. So this is another way that it can be phrased for you on presenting what the x and y values are. Here, if it's saying the amount in the account is a function of the number of weeks, whatever it's a function of is my x value. So here, x is going to be our number of weeks, and then our y value is money in the account. Once again, we're given how much money we start with, so that $100 is our y-intercept. And that slope, the rate that we're given, we're adding $5 every week. But here we are gaining that $5, so our slope is a positive 5. So our equation for part A for number 2 is going to be y equals 5x plus 100. Part B is asking us to write the equation or use our equation to find how long it will take to get $310. So now a little bit different because the number we're starting with is a dollar amount, and that correlates back to our y values. So now we're going to be plugging in that 310 for y and solving for x. So if I do that, 310 equals 5x plus 100, and now a simple Algebra 1 problem. Minus 100 on both sides, 210 equals 5x. I then divide by 5 on both sides, and I get x equals 42. It is a word problem, and all of these will be, so you just need to make sure you include your units, so 42 weeks. So that's slope-intercept form, and most of the time that's what I default to. If I'm not given both of those two things, you can figure out the rate or figure out the starting value based on the information that you're given. That's the form of the equation that most of us are comfortable using. But there is another way of handling that. If I'm not given something where we don't have the rate and we don't have the starting value, remember we also do have what we called point slope form. So slope-intercept form was y equals mx plus b. Point slope form was y minus y1 equals m times x minus x1. And here, x1, y1 is a point on our line, and then m is still our slope. So for this, we're looking for an example point for the situation that we're modeling, and then we do still need that rate. So if we are given that rate, that's ideal. If not, we can also find that rate using those 2 points. So for number 3, it's a very outdated call, and I need to probably update this into something more appropriate with maybe data allotment on your plan for anyone who doesn't have unlimited data. But let's just suppose Diane knows the phone call to a friend costs 25 cents for the first 3 minutes, and then 10 cents for each additional minute after that. The number of minutes you call and the cost of the call are related. So again, here just kind of defining what x and y are. If you think of converting it into something more up to date and appropriate to today, this would be like saying how many hours of Netflix you watch is then going to cost you so much based on how much data you're using of your data plan. So here, we're talking about minutes of the call and cost of the call, how long you are on the call. The time is what determines the cost, right? You're on your phone for longer, it's going to cost more. In this case, the numbers that we're given, 25 cents for the first 3 minutes, and then 10 cents for each additional minute. So that one, the 10 cents per minute after that, is actually going to be our rate. We're charged an additional 10 cents here for each minute after that. But the first part, 25 cents for the first 3 minutes, that's a point. So it's telling us that a 3-minute phone call, Diane knows, costs 25 cents. So if she's on the phone for 3 minutes, it's going to cost 25 cents. And then after that, it's just that flat rate of 10 cents per minute. So we can use these 2 data points with our solution, or our formula, to get our new equation. So here, this is our m, this would be our x1, this would be our y1, and we're just going to plug those together to get our equation in part A. So y minus 25 equals 10 times x minus 3. And you can leave it like that. You don't have to necessarily rearrange it into slope-intercept form if you don't want to. I am perfectly happy just leaving it as is. For part B, I'm asked to find the cost of a 30-minute phone call, which the 30 minutes, that's our x value, so we're just plugging 30 in there for x. So if we do that, y equals negative 25 equals 10 times 30 minus 3. That's not supposed to be an equal sign there. Y minus 25. So y minus 25 equals 10 times 27. So y minus 25 equals 270. So I add 25 on both sides, and we get 295 cents. So I would write that up as $2.95 for a half-hour phone call. Thank goodness we don't get charged that anymore. Now it's just flat rates. Everyone gets unlimited calls, and most people even have unlimited data. Although the plans are probably more expensive. Anyway, number 4. Number 4 is a little bit more complicated. This one's talking about some biologists that have discovered that there's a number of chirps some crickets can make per minute and it's related to temperature. The relationship is very close to being linear, so we're just going to assume that it is exactly linear. As you will find out later in life, if you are doing any kind of actual data collection, you're doing any kind of research, very rarely do relationships where we're trying to discover them follow an exact function. They're not perfectly linear, they're not perfectly quadratic or exponential. They just follow that pretty closely. So anyway, in this case, when the crickets chirp 124 times a minute, it is about 68 degrees Fahrenheit. And when they chirp 172 times per minute, it's about 80 degrees Fahrenheit. Now, this one is, again, a little bit confusing because the way it's phrased, it seems like the number of chirps determines the temperature. But when you think about that logically, that's absurd. The number of times a cricket chirps per minute is not going to change the temperature of the room. The cricket is chirping at a particular rate based on the temperature it's experiencing. So in this case, my x value is actually going to be temperature, and my y value is going to be chirps. The two pieces of data that I'm given, so we're told 124 chirps per minute at 68 degrees, and then 72 chirps per minute at 80 degrees. Both of those are points, so I've got 68, 124 and 80, 172. Those are my 2 points. Again, temperature, x, y, temperature, chirps. So with this one, because I don't have the rate, I have to use my slope formula to find that slope in order to use either of my two equations. So for my slope formula, I'm just going to do this off to the side. Remember, the way I would calculate slope is y2 minus y1 over x2 minus x1. And in this case, it doesn't matter which one you call, x1, y1, x2, y2, you're still doing the same process. So in this case, 172 minus 124 over 80 minus 68. So when I do that, I end up with 172 minus 24 is 48. 80 minus 68 is 12, which reduces to just 4. 4 chirps per minute, or per degree. Chirps per minute per degree. That would be the weird unit of my rate. So it's saying that for every degree that my temperature increases, I'm going to increase 4 chirps for every degree per minute. So from here, it's up to you on kind of how you proceed. You've got two different points that you can choose from. You've got your slope, so you can use slope-intercept, or you can use point-slope form for that. You could, if you want to get really fancy with it, could work backwards to figure out your y-intercept to slope-intercept form. I'm just going to choose one of those 2 points to write my equation. And when I do that, I usually just default to whichever ordered pair is smaller. So my equation that I would write for this situation would be y minus 124, because that's y minus y1, equals my slope, which we figured out is 4, times x minus x1, which is 68. So that's the equation that I have set up. Now for part B, they're asking us to identify what's the temperature outside if we know that the crickets are chirping at 150 beats or chirps per minute, times per minute. So now this one, my chirps per minute is my y value. So we'll be plugging in 150 in for y, and then just solving from there. So x minus 68. So 150 minus 124 is 26, equals, I'm going to go ahead and distribute my 4 into this parenthesis just to kind of simplify the next step of the process. So that's 4x minus 272. Now I'll go ahead and add 272 on both sides. 4x equals 298. And when we divide by 4 on both sides, we get x is 74.5 degrees Fahrenheit. All right, that's all I got for you guys today. Your homework is actually a worksheet. It's posted on Google Classroom. It's very, very similar to this. It's just 4 problems. Where again, it's going to be set up the exact same way as this. You guys will be able to kind of go back and forth and follow along with this video if you need to. As always, tomorrow you guys will have the class period to work on that homework assignment. So those 4 word problems, you'll have all class period to work on it. If you want to take a look at them, just to kind of see if you're setting it up correctly, and just have those questions ready at the beginning of class tomorrow. We'll go through and I'll kind of provide any clarification that's necessary on this set of notes. And then you guys will have time to, again, ask questions on the homework or just work on the homework. So that's all I got for you guys. Have a fantastic night, and I will see you tomorrow.